Section 4.5 is negative exponents and reciprocals. We're going to go back to grade 9 for just a minute, and we're going to talk about our exponent rule. And our exponent rule for grade 9 said, if you're dividing powers and the bases are the same, then you're going to keep the same base and you're going to subtract your exponents. You may also remember the rule written this way. Example 1. We're going to use this exponent rule to explore what happens if you get a negative exponent, and we're going to complete the table together. So if we look at our exponent rule from grade 9, I'm dividing powers, the bases are the same, I'm keeping the same base, and I'm subtracting those exponents. If I do my subtraction, 5 subtract 3, written as a power, this would be 10 to the power of 2. We're going to look at this written out what I call the long way. So if we have 10 to the power of 5, that means 10 is used as a factor 5 times. That's in the numerator, or upstairs if you will. 10 to the power of 3 in the denominator, or downstairs, means 10 is used as a factor 3 times. But what happens when a number is divided by itself? So 10 divided by 10 is 1. I can do that again, and I can do that again. When I look at what's left, I have 2 factors of 10 in the numerator, and I can write that as 10 squared. Let's look at that now. If we have 10 to the power of 3 in the numerator and 10 to the power of 5 in the denominator, the rule is I keep the bases the same, I subtract my exponents. So I need to complete 3 subtract 5. Well, 3 subtract 5 now is negative 2. We get a negative exponent. If we look at this written out in product form, in the numerator, 10 is used as a factor 3 times. In the denominator, 10 is used as a factor 5 times. And then again, 10 divided by 10 is 1. I can do that again. I can do that again. So if I look at what's left in my fraction, I have all of the 10s in the numerator canceled. But remember, 10 divided by 10 was 1. So to keep that space, we really have 1 multiplied by 1 multiplied by 1. So I need that 1 in the numerator. I look at my denominator, I have 2 factors of 10 left over, so that's 10 to the power of 2. Let's look at that with variables. Same idea. X to the power of 4 divided by, remember, x to the power of 1. If it's not written there, it's understood. The rule is keep the base the same, subtract my exponents. 4 subtract 1 is 3. And again, the long way works the same with variables. I have x is used as a factor 4 times in the numerator. X is used as a factor 1 time. Again, any number or variable divided by itself is 1. And then when I look at what remains, I have x to the power of 3 in the numerator. We'll work with the denominator now. Remember, this is x to the power of 1. Subtract 4, so the rule stays the same. 1 subtract 4 is x to the negative 3 this time. So let's go the long way. I have 1 factor of x in the numerator. I have x used as a factor 4 times in the denominator. A number divided by itself is 1. That leaves me with 1 over 1, 2, 3 factors of x, so x to the power of 3 in the denominator. We're asked to compare the 2 columns that contain the power form. So let's just go back to the 10. Base 10, if I look at my power form, 10 to the power of 2, 10 to the power of 2. They're equal. For this question, 10 to the power of 5 divided by 10 to the power of 3, the answer can be written as 10 squared. Both of those are equivalent. If I look at 10 to the power of 3 divided by 10 to the power of 5, these answers are also equivalent. So 10 to the power of negative 2 and 1 over 10 squared are both the same answer, but written in a different form. Base x's, my power forms are exactly the same question, same answer. When I look at my question with x to the power of 1 over x to the power of 4, I have x to the negative 3 and 1 over x cubed. These answers are equivalent. They answer the same question. So when we look at part B here, what do we notice? Well, what we notice in those two columns is we have this negative exponent, and that's new to us. And if we look at that negative exponent, it can be written as a positive exponent by getting the reciprocal of the base. So let's just take a quick look. Reciprocal, remember, is when I take my base and I write it, let's say, upside down. So my base is 10. When I rewrite my exponent here as a power form, the reciprocal of 10 is 1 over 10. Now my exponent is positive. If I look at my x to the negative 3, I rewrite it as a positive exponent, but the reciprocal of x is 1 over x. Part C. Write an exponent rule for writing negative exponents into positive exponents. If we have a base with a negative exponent, which is any number, we're going to rewrite that as 1 over the reciprocal, remember, keep the base, make the exponent positive. Or another rule we're going to look at is what if the negative exponent is already in the denominator? Well, when I flip over 1 over x, I'm going to get positive x, and my exponent goes positive n. We're going to look at these two relationships in some examples in this section.